Right, and we're back again, and we're back for the 24th of Jan. This is the Further Maths 5 a day, and we have 4 questions, although having a quick look at the third question, that looks quite lengthy. But let's start with the first question and work our way through. How many points of intersection does the circle x squared plus y squared equals 8 have with the line x plus y equals 4? Now, what I'm going to do, I'm going to do my usual simultaneous equation. So I'm going to say that y equals 4 minus x. And I'm going to substitute that into this circle equation. So that's going to give me x squared plus y squared, which is now 4 minus x squared, is equal to 8. And let's expand that. So I've got x squared plus 16 minus 8x plus x squared is equal to 8. And let's tidy this up. So that's going to be 2x squared minus 8x. 16 minus 8 is 8. And that gives me 0. And I can see where this is going. So it's going to be x squared minus 4x plus 4 is equal to 0. Now, crucially, this factorizes down to x minus 2 squared. In other words, if this equals to 0, the only solution is x is equal to 2. However, we need to be careful. Just because x only has one value doesn't mean that y can't have multiple values. But because this is a linear equation here, for each value of x, there is only one value of y. So therefore, it's the case that x equals 2 leads to only one solution. So the answer to the question is there is one point of intersection. Clever question. Next question. Work out the rate of change. Now, rate of change means you are going to think differentiation. You can't differentiate with product rule yet. You may be able to, and if you can do that. That's fine. You can do that in exams. You can use any maths you know as long as it's proper good maths. But most of you will probably have to do the method where you expand it first. So that's going to be x cubed minus 4x squared, which means if I differentiate, so we're going to bring down the power, take away 1 from the power. So that's 3x squared. Bring down the power is 8. Take away 1 from the power is 1. And then I want to know dy dx at the value x equals 3. So that's going to be 3 times 3 squared, which is 9, so that's 27, minus 8 times 3, which is 24. 27 minus 24 is 3, so my gradient is 3. Good question. Next one. This looks horrible. Okay, so this is just going to be an algebra being careful exercise. And I'm going to do it what may not be the quickest way, but I'm going to do it the way that I feel safest doing it. And that's what I'm going to observe which ones work better. Yeah, and I'm going to use the x values. So I'm going to make the x values disappear, which is going to leave me with 2 functions with y and z in, solve the y and z, and then put it back in to get x. I do have quite a bit of space, but there is going to be a little bit of squishing at the margin. So let's do, I want everything to be 20x, so let's do 2 times equation 1. So that's going to give me 20x plus 120y plus 20z is equal to 50. So that's equation 1. Then I'm going to do 4 times equation 2. Remember, I want 20x. That's going to give me 20x plus, well, 4 times 40 is 160y. Some of these are annoyingly big numbers. 4 times 20 is 80z. And then I've got 4 times 40, which is going to give me 160. And equation 3 already has 20x's, so I'm just going to write that one down here. So 20x plus 20y plus 40z is equal to 30. I'm going to label these equations 4, 5, and 6. Now, let's carry on doing it underneath, because I'm not sure how much space I'm going to have. So I'm going to do equation 4 minus equation 5. So it's 20x minus 20x, that's fine. 120 minus 160, which is minus 40y. 20 minus 80, I've got the feeling it's all going to be negative. 20 minus 80 is minus 60z. I should have done it the other way around, shouldn't I? And 150 minus 160 is minus 110. Now they're all negative, so I'm going to change them all to positive because that's fine, because I'm multiplying everything by minus 1. And then I'm going to divide everything by 10, which is going to give me 4y plus 6z is equal to 11, and I'm going to call that equation 7. Now, what I'm going to do, so I've used equations 1 and 2, so I'm going to do equations, what should I do? I do equation 1 and 3, so 1 minus 3. So that's 20x minus 20x goes away. 120 minus 20 gives me 100 y. 20 minus 40 is minus 20z, and 50 minus 30 is 20, which gives me this equation here. So let's simplify this a bit, divide by 20. So that's 5y minus z is equal to 1. Let's call that equation 8. But then what I'm going to do, because I need to make simultaneous equations from 7 and 8, is I'm going to multiply equation 8 by 6. So that's going to give me 30y minus 6z is equal to 6, and we'll call that equation 9. Then I've got equation 7 has plus 6z, equation 9 has minus 6z, so I'm going to do equation 9 plus equation 7. So 30y plus 4y is going to be 34y. I'm hoping for a 17 here. 6z minus 6z goes away, thankfully. And 6 plus 11, yes indeed, we do have it, is equal to 17, which means that y is equal to a half. That's not very nice, is it? I was hoping for an integer. Now, what should we do? Let's put that back into equation 8. So 5 over 2 minus z is equal to 1. So 5 over 2 minus what is equal to 1? It means that z must be equal to 3 over 2. Is that right? 5 minus 2? Yeah, 3 over 2. I've got y, I've got z, now I need to find x. So there's no easy way of doing this, but I'm just going to jump into, let's just do the first equation. So let's go back to equation 1. So 10x plus, don't mess it up here, we've done all the hard work. 60 times a half, good, that's a nice number, plus 10 times 3 over 2, that's a nice number, is equal to 25, which means that 10x plus 30 plus 10 over 2 is 5 times 3 is 15 is equal to 25. 30 plus 15 is 45, minus 25 is 20, divide by 2, which means that x is equal to minus 2. Wow, that's a lot of work. So therefore x equals minus 2, y is equal to a half, and z is equal to 3 over 2. Now let's remember, if you have a class whiz, you can put that in your class whiz, double check the answer's correct, make sure you've done the right thing before you move on. Good but difficult question. Next and final question today. How many solutions of tan x equals k where k is less than 0? Oh, okay. After the last question, this is not too bad, is it? Let's draw the graph of tan x between 90. So there's 90, there's 180, there's 270, and there's 360. And the graph of tan x looks something like this. So it goes up like this, and then it comes across and over and up, and then it comes up and over. And then my line x equals k, where k equals negative, it goes ding, 1 and 2. And so the final answer is going to be 2. Relatively easy question to finish off a difficult day where we did quite a bit of maths there. As ever, if you did all of that, got it all right, well done. Do like, subscribe, leave a comment below. I will go back to you, and I'll see you for the next one. Thanks all.